Okay, this is the P4 paper from January 2024. This is question number 9, which is the last question on the paper. It's differentiation, in particular parametric differentiation. We're going to be just finding dy by dx and then working out an equation of a tangent. And then this last part, it looks like we're going to try and work out the Cartesian equation for this parametric one. But let's make a start. Part A, finding dy by dx. So if I'm asked to find dy by dx, what I'm going to start with is so x is equal to sec t, so let's get dx by dt. Differential of sec is sec tan, so sec t tan t. And if I've got y is equal to root 3 tan t plus pi over 3. That doesn't look very nice, but it's actually not that difficult to differentiate. When we're differentiating, well, the root 3 doesn't change, does it? And the differential of tan is just sec squared. So it's sec squared t plus pi over 3. And because we've only got a t in there, there's no complications about multiplying by the differential. We just get that as being dy by dt. We want dy by dx. So dy by dx is going to be dy by dt times dt by dx. That means we're going to need to flip that one upside down. No real issues with doing that. So I'm going to get that equals dy by dt root 3 sec squared t plus pi over 3, and then 1 over sec t tan t, I'm just going to write as divided by sec t tan t, and it just says find dy by dx, doesn't say anything else, so I'm quite happy to leave that as my actual answer for that part, as they haven't asked me to simplify it in any way. Okay, on to part B. Part B says find the equation of the tangent at the point where t equals pi over 3, and give the answer in the form y equals mx plus c. Right, well, part B then, if I want to do it, I'm going to use the formula y minus y1 equals mx minus x1. That's how I find the equation of any straight line. But what I need to do is to find x1, y1, and m. So let's explain to the examiner I'm going to do that. So at point t being equal to pi over 3, x1 is just going to be sec t, sec pi over 3. So do that on your calculator. That works out to be equal to 2. y1 is going to be root 3 tan pi over 3 plus pi over 3. Well, I'm actually going to call that 2 pi over 3, save myself a bit of time there. Root 3 tan 2 pi over 3. Put it into the calculator. Comes out to be minus 3 there. And m is going to be putting pi over 3 into our gradient function. Our gradient function was root 3 sec squared, and in this case 2 pi over 3 all over sec pi over 3 tan pi over 3. Yeah, remember the function was that function there. So sticking pi over 3 into all of those, that works out to be equal to 2. So the equation of the tangent, so I'll write it out again, y minus y1 equals m x minus x1, and we now know all of those values. That's y, just be careful, y plus 3 equals 2x minus 2, so that's 2x minus 4, then minus another 3, that's y equals 2x minus 7. Go back and check, but I did just look at it, didn't I? They want it in the form y equals mx plus c, so we're sorted out. Excellent. Okay, on to the last part. So last part of the last question, obviously might be a bit challenging. To be perfectly honest with you, I did this wrong when I did it the first time. What I actually tried to do to start off with was I put x in there, and tried to see if I could then get it to look like y equals. But what I didn't really take account of, and it was only spent about 5 minutes doing that, and then thought, no, I can't get the t plus pi over 3 part to it. So that then made me realise, I looked at it and went, oh, of course, yeah, no. What they actually want me to do is to start off with this side. There are other ways of doing it, but personally, this is the way that I found easiest, was to start off with y, call it tan of a plus b, and then you've got tan a plus tan b over 1 minus tan a, and you can get going with it that way. So just trying to give you a little bit of an insight into why I did this way was actually, I got it wrong the other way. I had a little bit of time to myself, so I was able to go back and have another rethink. So I think this is the simplest way of doing it, is to say, we know that y is equal to root 3 tan t plus pi over 3. So all I'm going to do is to focus on this bit and expanding that out, and then I'll have a look back at seeing whether I can try and get it to the answer. So the first thing I did was to just make it clear to the examiner that tan of a plus b is tan a plus tan b over 1 minus tan a tan b. So in this case, y is then going to be equal to root 3, and it's going to be, all right, tan t tan pi over 3 all over 1 minus tan t tan pi over 3. But tan pi over 3 is root 3. So I actually get y is equal to root 3. Okay, so this is going to be tan t plus root 3 all over 1 minus tan t times root 3. Now I don't like that written down that way round, so once I did have it like that, I just made it root 3 tan t. Just makes it a little bit clearer when I'm going through doing a lot of algebra here, to try and keep it in terms of not making a mistake there, not making a mistake with that part when I'm doing it. So then I did have a quick look at the answer and said, right, okay, what am I trying to get? Well, I need to get x into my answer here, and x is sec t. So at some stage, and this is where I decided to do it, at some stage, you've got to think about getting that sec t in, and sec t in terms of tan, hopefully your trig identities are still strong enough that you know that, and so you think, all right, well, okay, that's x squared then is 1 plus tan squared t, so x squared minus 1 will be equal to tan squared t. So in other words, tan t is the square root of x squared minus 1. So what that now means is that I can get rid of the tan t's out of there, and I'm actually replacing them by x's. Root x squared minus 1, but I'm replacing them by x's. Okay, so if I'm going to do that then, just be careful when with all your copying errors as we're going through and doing this. So y is now, y is now going to be equal to, anywhere where there was a tan t, I'm going to put root x squared minus 1. So I had root 3, root of x squared minus 1, just be really careful with the way that you're setting this out now, plus root 3, all over 1 minus root 3 root x squared minus 1. So if we're doing that, I'm just going to multiply that top bracket out. So I'm going to get y equals, these two just become root 3 x squared minus 1, and I'll tidy that up in a second. Root 3 times root 3 is 3. All over, I'm going to do the same on the bottom, 1 minus root of 3 x squared minus 1 there. So then I start sort of looking towards the answer, how close I am to the answer, but really I shouldn't do anything until, with this bottom one, we've got to rationalise the denominator there. We can't have a surd on the bottom. So even if you got a little bit stuck at this stage, you say, oh, I'm really not sure what to do next, well, you should be at least happy to say, no, what I've got to do is try and get rid of the surd off the bottom, and the way to do that is to times by 1 plus the 3 x squared minus 1. Now, at any stage here, if you want to call that 3x squared minus 3, you could do it right now, or you could wait till the very end to do it. It doesn't matter, as long as you're not trying to do too many steps all in one go here. What I'm focusing on at the moment is the fact that this one times this one means that the square roots are going, rationalising the denominator. Right, so if I'm going to do that, then just be careful here with this next step. So in order to do this, then multiplying the top out, going back to IGCSE, where it's that times that, that times that, that times that, that times that. I'm just going to do all those things, but without all the arrows, and just being really careful. So this is going to be root 3 x squared minus 1. Well, I'm going to call this root 3 x squared minus 3 now. That's these two times together. Plus 1 times 3, it's 3, plus root 3x squared minus 1 times root 3x squared minus 1 is going to give us 3 lots of x squared minus 1, plus 3 times root 3x squared minus 1 is going to give me 3 root 3x squared minus 1. Well, as I say, I'm going to keep calling that 3x squared minus 3 now, all over, and then the denominator is a bit easier because it's this times this, this times this, this times this, this times this. When I'm doing that, the whole point about that is that the middle two values are going to disappear. I'm just going to get actually 1 squared minus that squared. And I'm going to do that really, really quickly. The whole point about doing these is to save ourselves a bit of time. So that's going to work out to be 1 minus 3 x squared minus 1. That's this multiplied by this. You want to take longer over that, you take longer over that. I don't want to do that if I'm in danger at any stage here of making mistakes. I want to try and keep my work as simple as possible when I'm just doing it. So we're really close to the answer now. These two are the same term here. So if I've got one of them plus 3 of them, that's 4 lots of 3x squared minus 3. Then I've got plus 3x squared minus 3. Well, that looks nice. And on the bottom here, I've got 1 minus 3x squared plus 3. That all then eventually comes to the actual answer that I had, which is 4 root 3x squared minus 3. The 3's cancel on the top there. I've just got plus 3x squared, all divided by, and then the bottom is 4 minus 3x squared. Right, very elegant solution, that one there. So yeah, we got to that part in the end. As I say, I actually went wrong first off. I tried to do it the other way around by starting off with this and trying to end up getting the y there. And really, it was the point at some stage of spotting that if I've got tan of a plus b, that certainly is a nice start off point. The other difficulty was then making sure that we rationalise that denominator. Okay, tough one, but it is the last question, so fair enough that they give us a tough little bit of algebra there. Hopefully that makes sense, and hopefully the paper will make sense to you as well.